A very good morning, ladies and gentlemen. Welcome to the group exhibit Hydrogen Fuel Cells Europe at Hanover Fairground 2023. I invite you all to come and have a seat here at the technical forum. My name is Mona. I'll be the moderator for today. There are two really lovely ladies walking around serving you drinks, complimentary. So yes, please come and have a seat. And enjoy our presentations. We'll be discussing the technology behind the hydrogen and fuel cell innovation. Every 15 minutes, we'll have a new topic. Up next, we'll have two speakers, and we will talk about the importance of ex situ characterization through electrochemical techniques. If you do want to know more about this, please stay tuned and welcome with me on stage Massimilano Boccia, R&D Manager of H2 Energy, and also Vincenza Marzocchi, Lab Supervisor at H2 Energy. A warm welcome.
Thank you. Thank you. Good morning, everyone, and thank you for the interest in our speech from H2 Energy. Today we are going to talk about the importance of the ex situ electrochemical tests. Usually these kind of tests are performed from the university and academic research center, but in H2 Energy we think that it is very important to make this test internally to the company, not only as material selection, but even as a quality control. Let me highlight that the result coming from all the electrochemical testing are not so simple from the interpretation point of view, and a high competence is required in order to understand the result coming from this test. For this reason, I'm very proud to introduce my colleague that is the lab responsible and the chief of the electrochemical division of H2 Energy, Vincenza Marzocchi.
Thanks, Massimiliano. I'll just go very fast on the introduction. The importance of the electrochemical ex situ characterization is not only my opinion, but the European Union, there is a protocol. There is a protocol that says us how to perform the right way for the good results. At the first time, there is a functional property of material, and then you make the ex situ test. After I talk you what I'm talking about. After to testing the material, we must to test the single cell and then the short stack. Obviously, you start with at the beginning of the test, doing everything. In the end of the test, if there is something wrong, you go to ex situ test for each material, which is in the European Union. There is this protocol. It's provide a different kind of the tests: physical tests, physico-chemical tests, electrical tests, and chemical. In the laboratory of H2 Energy, we are able to make a physico-chemical polarization curve, cyclovoltammetry, and electrochemical impedance spectroscopy, SEM with the DX analysis, and the rotating disk electrode. The physical test, we can able to make thickness, to calculate the water uptake, the mass loss, and the hydrophilicity. About the electrical tests, in the H2 Energy, we are able to calculate the ionic conductivity in plane, through plane, and electrical conductivity. In the end, we are able to make the chemical test with the rotating disc electrode, DHE measurement, and then the CP-EOS analysis. What is the polarization curve? The polarization curve is the basic for understanding the material and what happened during the solicitation. Give us information about the cinetic, give us information about the ohmic resistance and the transport of the cell in the stack. It's important because at the beginning of the test and the end of the test, the comparison between the two curves, the both results, you have information about the performance of your cell or of your material, because this kind of test it's possible to do on the material first, on the material with the catalyst, and on the cell and on the little stack. This is a typical curve that we can find the potential, the cell voltage on the epsilon axis, and then the current density on the horizontal one. Very low the current density, we can see very low current density. We can see the region, we can understand what happened to kinetic reaction. If very high value, the current density, we can understand what happened to the mass transport. And in the middle, there is obviously the region of ohmic polarization. The cyclic voltammetry is just a bit different from the polarization because it's a polarization, cyclic polarization. It's more used for the redox reaction to understand the catalyst, which kind of the catalyst, the redox reaction that happen on the surface. We are able to make this kind of the test in liquid solution and on the top of the membrane or which other, for example, electrode, stuff like this. This is a typical cyclovoltammetry that we have made inside our laboratory. Is for a very famous catalyst like a platinum. You can see that the curves are on the top. They aren't different because it's, we know everything, the platinum. This is a curve that we made on the membrane. I cannot say anything about that, but just to show you because it's our property. The most important, my favorite, I know, is the electrochemical impedance spectroscopy because this is a very powerful diagnostic method. I don't know if the people have the opinion about that, but you can use this one like a quality test during the operation, in the operation mode. What is it, the impedance spectroscopy? The impedance spectroscopy, you give to your material like a voltage at different, to open circuit voltage or different kind. Depend from how do you want to stress it or to understand what's happened, very high value. He give you the information, this kind of technique, give you the information about what's happened on the surface. Obviously, it's not easy to understand this kind of the test, but it's very, very important because he gives us information after to make like a equivalent circuit, because each material, you can to characterize it like a equivalent circuit. And then from this kind of the test, we can have information about the resistance, the transfer capacitance resistance, the conductivity. This is a typical test, Nyquist board from a membrane in 3 different times. the same one at the first time and the other one in the different moment. The red and the blue is a different day, different week. It shows us how many stable of your membrane. In this case, it's only a membrane, but you can do this kind of the test. You can use a membrane with the catalyst, or you can make the test with all of the cell. Thank you for your attention. Maybe I have to say you that we have just to report here the resistance, but we can't to report on the plot all the electrochemical. Thank you for your attention. Please contact us.
Thank you very much, the two of you. If you have any questions at this time, please raise your hand in the audience. I'm just scanning thoroughly. That's all right. You can take the questions to the booth. I very much appreciate your presence here. You can visit them at the H2 Energy booth. Thank you so much.